Hello, my name is Michael Mirsch, and today I'll be talking about the fluid properties having to deal with a syphon. Now the first question is, what exactly is a syphon? A syphon is when two tanks are connected with an inverse U-tube of unequal lengths. The unequal length of the U-tube creates a pressure difference where the higher tube has a higher pressure than the lower tube. This will later be explained as the reason why water continues to flow through the tube. Now, before getting too in-depth, I'd like to show a demonstration of a syphon real quick I made. Now, normally a pipette would be used to push air into the tube and slowly pull it out so that the water begins to flow, but I simply used my mouth like they did back in the movies. So, as you can see, when the water is pulled, the water will continue to pour through the tube until the higher container is either empty of water or matches the same water level as the container being poured into. In order to understand this concept better, we must first look at the syphon before the water is pulled through the tube. We notice that without water on the left side, the water level on the right is far higher than the other side. After the water has fully been siphoned through the tube into the other glass, we notice that the water level of both the taller glass and the smaller glass sit at the same level, which is what we should expect when a syphon is finished doing its job. This has to do with the gravitational potential energy of the water. In order to understand this better, we need to look at the equations governing the pressure through the siphon tube. The pressure 1, the container on the right, can be described as the atmospheric pressure minus rho times gravity times height 1, while pressure 2 is atmospheric pressure minus rho times gravity times the second height. We realize that H2 is greater, making P2 smaller than P1, allowing water to flow. Since the density and gravity values are the same for both containers, once the two heights are equal, the two pressures will also be equal, causing the water to stop flowing. One of the common misconceptions about the syphon has to do with atmospheric pressure. Some believe that the atmospheric pressure on the surface of the higher container causes the water to flow through the pipe into the other container. This is incorrect because while there is atmospheric pressure at the surface of the higher container, the equal atmospheric pressure on the other side would prevent the water from continuously flowing. This may stem from the idea of how a barometer works. Since the atmospheric pressure pushes the column of mercury up, some believe that it works the same as a syphon. This is not true because the vacuum at the top of the column is what causes the mercury to rise, not the atmospheric pressure. When people think of siphons, their mind may go directly to stealing gas out of a gas tank that they've seen in a movie or some kind of YouTube video. In the real world, there are actually very many applications that deal directly with our field of engineering. As a biological engineer, one of the best applications for siphons is in irrigation of farms. While there may need to be a mound to keep water in a confined reservoir, a syphon needs to be used to get the water out of the reservoir and to the crops. Without siphons, in this case, there would need to be an excess of outside forces rather than just relying on gravitational potential energy to help us water our crops. Today, we have learned that siphons are not as simple as they seem. We were able to relate pressure equations between the two tanks and debunk some theories about atmospheric pressure being the main driver of the water. While there are many applications of siphons in engineering, these were all I was able to talk about today. Hope you have a good day.